let's cover the 5th video of the best time to buy and sell stock series, in which you can have as many transactions as you want, as long as you don't have more than one stock at a time. You don't buy the stock, the very next day you sell it. The given constraints are the length of the prices is within 5,000 and all the prices are within 1,000. To me, the most intuitive solution to this question is the use of dynamic programming. For this question, I also tried to come up with a greedy solution with preprocessed results, like the solutions I derived for LeetCode 122, 123, and 188. But eventually, I could not think of any greedy property that I can utilize. So the focuses in this video will be 3 variants of dynamic programming solutions. The first solution I want to cover is the so-called top-down dynamic programming. Which is similar to the one that we used to solve LeetCode 188. If you haven't watched that video, I would strongly recommend you to check that one out first. As usual, we need to think about the transitions and statuses. Let's start with the statuses this time. There will be 3 statuses. The first one is we are holding stock, or we are not holding stock but in a cooldown. We just sell a stock right now, so we cannot buy it the very next day. We'll be not in cooldown. So there are 3 different statuses. On top of that, we also need to know which day we are in, right? So there is also the days dimension, and this is ON. This is O3. And that's the statuses. How about the transitions? We need to think about the transitions from each state to the other state. For our holding stock right now, there will be 2 possible outcomes. I can either keep holding stock, or I can actually sell it and now get into the cooldown state. How about if I'm not at cooldown? There's only one possible transition, which is to not in cooldown. How about if I'm not in cooldown right now? What will happen next? I can either do nothing. I will keep at this state, not in cooldown, or I can actually buy a stock, so I'll be holding stock. There are 3 different types of transitions, so this is O3. Before we move on, let's review the top-down dynamic programming structure. If I'm having a function called dp, the first step will be checking the corner cases. Like if I'm already at the end of the array, I should just return some default result. It will be followed by the memorization part. If we have visited this status before, then we should return the result immediately. And it follows by a transition block, which we just covered on the right-hand side. And lastly, there will be the update of memorization, and also the return of the result. All right. This is our second time covering this top-down dynamic programming structure, so this should be familiar to you. All right, now let's move on to the next variant of dynamic programming. One of the obvious strengths of using top-down dynamic programming is most straightforward solution derivations. However, most of the time, the alternative bottom-up dynamic programming will be faster or have lower constants in the time complexity. On top of that, in some cases, the bottom-up version can even have better time complexity or space complexity in the big O notation. That's the reason why we should learn how to derive both of the solutions. Now let's do bottom-up dynamic programming. One trick to keep in mind is that the traversal order between top-down and bottom-up dynamic programming is usually the opposite, because we are now trying to push the current answer to the future sub-questions instead of spinning out to the future questions, then using the future answers to update the current answer. Let me elaborate on this. These are the previous transitions between status for a top-down algorithm. For example, if I don't know the max profit I can get by holding a stock at the beginning of the day, I will delegate that question to 2 scenarios in the future. Holding a stock at the beginning of tomorrow versus selling a stock by the end of today and getting to cooldown by tomorrow. Basically, I delegate the question to the future, and I will figure out the maximum value by doing these two actions, and then update this whole stock status. However, in the bottom-up version, the holding stock status, this status, need to figure out how it is updated. Now, the whole stock status for the future, let's say I plus 1, will be actually the maximum of whole stock I, and not in cooldown. You can see the direction is the opposite. Now we are trying to update this whole stock from here and from here. Let's take a look at the other example. Cooldown in I plus 1, it will be from whole stock only. Whole stock I. Now let's look at the last example. Not in cooldown. I plus 1 will be from the maximum of cooldown I, and not in cooldown. That's how we update the 3 different statuses in the bottom-up dynamic program. You can see the order is totally the opposite. Now let's think about how this is done in the for loop. We have a for loop from I equals to 0 to n minus 1, and we keep doing this. And in this approach, we need to have 3 arrays, whole stock, not in cooldown, and cooldown arrays, each with n plus 1 space complexity. However, if you take a closer look, we are always using the I value to update the I plus 1 value. Optimization we can have is to reduce this space complexity from n to just 0,1. We just need to have 3 arrays of 2 values. This trick is called the use of rolling array. And this is an example of how you can get better space complexity from using bottom-up dynamic programming rather than the top-down dynamic program. All right, now let's move on to the coding part, and we'll implement all 3 variants of the solutions. Now let's start with the implementation of the top-down DP algorithm. Top-down DP algorithm. We will first start with having these variables as instance variables so that we can use later. I need to know the length of the array. And I also need to deal with the memorization part, which will be none or underscore equaling 3, because there are only 3 status we care about, which are holding a stock or in cooldown, but not in cooldown. I need to have the status for each day. And here, I will need to make a code to the dynamic programming function, starting with day 0, or the first day, and the status. I will start with the status with not in cooldown, so I can buy the stock at the very first day. Now let's fill in the content for the DP function. It's, again, an instance function. There will be a position, it's an integer, and also the status, which is also an integer, ranging from 0 to 2. And we return an integer as the mixed profit. I'll start with the check on the cloner cases. Position, if it's at the end of the array, I will return 0 directly, because there's no more profit I can get. After that, I will need to check if self.record position status has been visited. If this is none, I should just return this value directly, because we have visited this status before and we know the answer at this moment. Other than that, I will need to actually do the transitions. There will be 3 cases. When status equals to 0, something. If it's 1, we need to do something else. And at the end, the status could be 2. After the transition updates, I will need to keep this value in the record. Self.record position status will be updated with the next profit value. So return this next profit value. Right. Now, if we are at the status of holding a stock, what will happen next? The next profit will be from 2 cases. The first case is that I might be at the same holding stock status. So I'll do self.dp division plus 1, that will be staying at 0. Or I can actually sell a stock. I'll move on to the next day, but once I sell a stock, I'll be in a cooldown status. But I can get the price of selling that stock. Now, when I'm in the status of in cooldown, there's one option for me, which is .dp +1 and move on to no cooldown status, so I can buy the stock afterwards. Lastly, if I'm now in a no cooldown status, again, two options for me. I can either do .dp position +1 and stay at the same status, or actually buy the stock. I'll be position +1, I will be in the holding stock status minus the price I pay to buy the stock. Now let's see if it works. Again, we need to add self notation in these places. All right, now we passed the test cases, and let's do submission now. You can see the speed is pretty decent at around 45 ms, and it is around 70% of the users. But now we're going to move on to the bottom-up solution. The speed will be even faster than this. Now let's start the implementation of the bottom-up DP algorithm. I will reuse these signatures here. Now this is the bottom-up DP algorithm. Again, I will first calculate the length of the array as the variables n. I will also want to keep the status in the variable called record. This time, I would like to initialize the values with negative infinite number. The infinite number needs to be large enough such that we will never reach this value. I would say like 10 million should be large enough. Now I would do minus infinite number for underscore in range 3. It is for n+1 array here. Now, remember that before we start, the record 0 and 2 is actually a valid starting point. That's the status where at the first day, we haven't bought anything, so we're not in cooldown. We actually need to change this value to 0. For all other cases, they are all negative infinite because they are not valid cases. We'll later update those status. Now, we would like to start with index from 0 to n-1. And let's think about the transitions. First of all, the very first transition is status 0, which means we are now holding stock. Now we think about how would you get to the holding stock status at index +1. There are actually two possibilities. First of all, you might be already holding stock at index. There are cases you are actually not in cooldown status, and now you actually pay the price and buy a stock. Now you will get into holding stock status today. How about the cooldown status? You will be in cooldown status today if you were selling stock yesterday. So we will know the record is from record index 0 plus the prices you will get today. Lastly is the status of not in cooldown. You'll get here by doing two things. You were either already at no cooldown status yesterday, or you were at cooldown status and after a day you are not in cooldown anymore. Now, at the end, once we update the record n times, now everything should get into record n position. There are three status here, but actually we don't care about the first status, status 0, because at that status, we're still holding a stock. So that will not give us the max profit. We can skip that one and just doing the maximum value between n1, which means you just sell a stock, or you'll be record n2, which means you sell a stock slightly earlier, and now you are in no cooldown status. And now let's do a run to see if it works. Okay, it passed two cases, and let's now do submission. Okay, you can see it's slightly faster because we now save quite some time from not doing recursive function. The last implementation we'll cover is to do bottom-up, but with rolling array. Again, I will copy-paste this function and comment this part out. And let's do the rolling array version. The change needs to be done here is actually pretty small. Instead of actually having n+1 array here, we actually need only 2. Because we shrink the array from n+1 to 2, we actually need to maintain which array we need to update. So I introduce a variable called flag here. It will be changing from 0 to 1 back and forth. This one is not index +1 anymore. This one will be 1 minus flag, so that it will be always 1 or 0. But the flip side, this one will be flag. This one will be flag. This one will be 1 minus flag. 1 minus flag. That'll be flag. Flag. Flag 2. This is also flag. And in the array, we need to flip it. All right, now let's see if it works. Let's do run here. Okay, it passed all the test cases and do submission. You can now see it actually beats around 95% of users. The reason it is faster is because previously we actually need to do the initialization for the huge record array, but now you don't need to do so. You only need to do it for the first 01 element, and then later on, the updates will happen automatically. These are 3 different variants of the implementations to solve this question, and I hope you like it. Thank you for watching.